Okay, this is problem 2.53. Page 62, University Physics. It says the acceleration of a motorcycle is given by a sub x of t equals at minus bt squared, where a is 1.5 meters per second cubed and b is 1.20 meters per second to the fourth. The motorcycle is at rest at the origin at time t equals 0. Find the position of velocity as a function of time. Calculate the maximum velocity it attains. Okay, so this is just like we did in the previous problem. V sub y of t is going to be the integral of a sub y of t dt. In this case, we have that the acceleration, and this is actually x, but it doesn't really matter in terms of, just so we're consistent here. So the x component of velocity and the x component of acceleration. So the x component of acceleration is 1.50 meters per second cubed t. I have to pull this over. Minus b, which is 0.120 meters per second to the fourth, times t squared. That's the acceleration as a function of time. So we integrate this, and the integral of t is t squared over 2. So we're going to hit t squared, and we're going to divide that by 2. So we're going to end up with 0.75 meters per second cubed t squared minus. So here we get t cubed over 3. 0.120 divided by 3 is 0.0400 meters per second to the fourth t cubed plus our arbitrary constant c. So t cubed over 3, I divide this by 3 and I get that. T squared over 2, I divide that by 2. And using the initial condition that the x component of the velocity at t equals 0 is 0 meters per second, what that would tell us is, again, that c equals 0 meters per second, because you'll stick t equals 0 in here. So you get 0 plus c is equal to 0, therefore c is equal to 0. So v sub x as a function of t is 0.75 meters per second cubed t squared minus 0.0400 meters per second to the fourth t cubed. Okay. Then to find the displacement x as a function of t, we integrate the velocity, the x component of the velocity. So this is my x component of the velocity. So we integrate 0.75 meters per second cubed t squared minus 0.0400 meters per second to the fourth t cubed, whole thing times dt. So when we integrate t squared, we get t cubed over 3. This divided by 3 is 0.25 meters per second cubed t cubed. Here we get t to the fourth over 4. This divided by 4 is 0.0100 meters per second to the fourth times t to the fourth plus our arbitrary constant c. So that's my displacement. Again, x at t equals 0 is 0 meters, because it says it starts from the origin. Therefore, c equals 0 meters in this case. So my displacement as a function of time is 0.25 meters per second cubed, t cubed, minus 0.0100 meters per second to the fourth, t to the fourth, plus 0. So there you go. So those are the, that's the first thing. So let me just check to make sure I did that right. So the displacement is 0.25 t cubed minus 0.01 t to the fourth. Velocity is, yep, okay. So that's part A. Part B is calculate the maximum velocity it attains. So the expression for the velocity, v sub x of t, is 0.75 meters per second cubed t plus minus 0.0400 meters per second to the fourth t, this one's t squared, this one's t cubed. Okay, so the maximum velocity is when what we do is we take the derivative with respect to time of v sub x of t, and we set that equal to 0. So we're looking for a maximum. So if you take the derivative and set it equal to 0, you find either a minimum or a maximum in this case. So if you take the derivative of this with respect to time, which actually is the acceleration, but we're just looking at the slope of the curve. You know, if you look at v sub x as a function of time, it's going to look something like this. And there's going to be some time where it reaches a maximum. It's going to have a 0 slope. The v sub x is a function of time slope. So what you get is you get 1.50 meters per second cubed t minus 0.0400. Okay, well, we're going to multiply that by 3. The derivative of t squared is 2t. The derivative of t cubed is 3t squared. So if I multiply this by 3, I'll get 0.120 meters per second to the fourth times t squared. And you set that equal to 0. So we get 1.50 meters per second cubed times t minus 0.120 meters per second to the fourth times t squared equals 0. So you factor out a t, you'll get t times 1.50 meters per second cubed minus 0.120 meters per second to the fourth times t equals 0. So one is when t equals 0 is a solution. The second solution is when this goes to 0. So if you solve for t there, you'll get 1.50 meters per second cubed divided by 0.120 meters per second to the fourth. So what I've done here is I've taken this and moved this to the one side, so it becomes positive, and then I divide by this coefficient. So if we get 1.5 divided by 0.12, I get 12.5 seconds. So that's the time where the velocity is a maximum. So, and actually t equals 0 is when it's a minimum. So now what we can do is we go plug that back in, this time into the velocity. So the actual value of the maximum velocity is where I plug it this time I got from setting the slope equal to 0 of the curve. So I get that, and let's plug it in. So you get 0.75 times 12.5 squared minus 0.04 times 12.5 cubed. And I get the maximum velocity, which is at this time is 39.1 meters per second. And that's the right answer.